Okay, so today we're going to do some examples from the formulas, using the formulas that you found yesterday of triangles and technically quadrilaterals, because all of the ones that you found other than triangles were quadrilaterals, a square, parallelogram, and a rectangle. So we're going to do some examples, so you should be on page 54 of your journal. Okay, here's our first two examples. Looking at those, they are parallelograms, okay? They are parallelograms because we've got parallel sides, two pairs of parallel sides. Now, one thing that we need to note, anytime we have parallelograms, rectangles, triangles, whatever, anytime we use the word height, anytime we talk about height, put this at the top of your notes, okay? Anytime that we talk about height, the height has to be perpendicular to the base. It's not the height unless it's perpendicular to the base. Okay? All right, so let's look at the one that we have drawn here. Everybody needs to sketch that very quickly. This is example number 1. And you'll notice also that we have marks that say that all of these sides are congruent. Well, that makes it a rhombus, yes, and we do have a formula for a rhombus, but also don't forget a rhombus is a parallelogram. So I don't have diagonals in this rhombus, so I can't use that formula. But I do have a base. I just need my height. So let's go back and let's think about what do we know about quadrilaterals. We should know something about opposite angles. What do we know about opposite angles in quadrilaterals? They are congruent. So if this one right here is 60, then this one right here is what? 60. So this one is 60 also. So now if you look right here at this triangle, if you look at that triangle, I've got a 30, 60, 90. And so therefore I can find out some missing pieces. First of all, since this side and this side are congruent, if this one is 24, then this one is also what? 24. Now that is the hypotenuse of this right triangle right here. And if it's the hypotenuse, go back to your blue paper. You might have that open. The hypotenuse, the short leg. So I'm going to use that right here. First of all, I'm going to use my 30, 60, 90 to help me find some missing pieces. Because remember, we're not in elementary or high school anymore. So I'm going to say, okay, my short is half the hypotenuse. That's one of our formulas. We say, okay, the short's half of the hypotenuse, so the short, we don't know, is half of 24. So x is 24. So now that means that this little piece right here, it's 12, sorry, is 12, okay? Now you go, well, okay, good, because technically I know that this whole thing's 24. Yeah, but that's not what we're looking for. We're looking for this height. And remember, the height has to be perpendicular to the base. I didn't say the base had to be on the bottom. It's just that the base and the height are always perpendicular. So always look for your perpendicular symbol, okay? Now, if I know that that short leg is 12, how do I find my hypotenuse? Well, the height. The height happens to be across from the long leg, the 60. So the long is the short times the square root of 3. So my long is my height, and my short is, what did we find it to be? 12 times the square root of 3. Now I have my height. do not worry about a decimal yet, okay? That's my height right there. Now, do I have the height and the base of my parallelogram? Yes. My height is 12 square roots of 3, and my base is, pay attention, what was this whole length? This whole length, if this one is equal to that one, the whole length is 24. So I have it. My formula is area is base times height. Area is base is 24. Height is 12 square roots of 3. Now, I cannot multiply by the square root of 3. That's not 3. Get it in your brain. It's not 3. What's 24 times 12? 288. So all I have to put is 288 square roots of 3. Now, if you are insistent, you multiply 288 times the square root of 3. But by golly, if you're going to do that, you better round appropriately. So if you're going to multiply, you better, by golly, round correctly, or I'm not going to give you credit, okay? So 288 times the square root of 3 is 498.8 because we're going to round. 498.8. We round to the nearest tenth unless otherwise specified. Okay, so now let's go down to this one right here. Parallelogram again. Notice I've got some markings that are the same, okay? So let's draw that same altitude from here. It is perpendicular, so it is a right angle. What kind of triangle do I have right here? A 45, 45, 90. And you go, but I don't know anything. Oh, but you do. I could even go with the fact that opposite angles are congruent. I could start over here. This one's 45. So I know this, but I also know this one. It's just the first one I saw. I know that it is 15. Now remember, I'm dealing with a 45, 45, 90. So if I have my hypotenuse and I want to find a leg, remember, in a 45, 45, 90, the leg is the hypotenuse times the square root of 2 divided by 2. So I'm going to put the leg is 15 times the square root of 2 divided by 2. That is not 2. It's the square root of 2. You cannot get it in your brain. So now 15 divided by 2 is 7.5 square roots of 2. Just leave it for a little bit. That is this leg, but it's also this leg, which is my height. 7.5 square roots of 2. Now do I have my base and my height? Yes. So my area is base times height. My area is base 30 times height 7.5 square roots of 2. And when I multiply 30 times 7.5, I get 225 square roots of 2. And you can leave it that way, but if you insist, you better round correctly. And when you round correctly, it should be 318.2. Okay? Okay, so let's go to the next one. Let's look at another one using our formulas. Draw this one. And as you draw it, notice it's a triangle. And not really sure why they felt the need to do this, except it's going to help us find our height. So that's probably why they did it. Okay, so now remember, in our triangle, we are trying to find in this triangle right here. This is our triangle that we're working with, okay? All right, so when we're looking at this one, we need our base and our height because the formula for the area of a triangle is 1/2 of your base, your height. Remember, perpendicular. They must be perpendicular. Height has to be perpendicular to your base. So I've got my base. And why do I call that the base? Because I see perpendicular here. If that's perpendicular, it's 90 here. Then this right here must be my what? It's my height. I just don't have the height. But before I go any further, I'm going to use a squared plus b squared equals c squared because if you look at this triangle right here, I've got a leg and a hypotenuse. I have 3 squared plus, we don't know squared, which is our height. Let's make that height. Squared equals the hypotenuse squared, which is 5. Then I have 9 plus h squared equals 25. H squared equals 16. And so h is what? 4. So now I know my height is 4. Now can I figure the area of my triangle? Yes. So I say the area is 1/2 base times height. 1/2 times the base is 15. It is not 18. This right here is not a part of your shape. If it's dotted, it's not a part of your shape, okay? So I have times 15 times 4. And when I do that, I end up with 30. Okay, let's do one more. Draw this shape. Notice I've got some dashed lines. That means they're not a part of the shape. Okay? So I want you to focus on the shape. And they do this for a reason, these parallel things right here, because these are the only two sides that are parallel. So therefore, what kind of shape is this? Hello? Yep, it's a trapezoid. It's a trapezoid. It's just on its side, okay? All right. Now, you remember these are going to be your bases. The bases of your trapezoid are your parallel sides. So those are your bases. So I have my base 1, I have my base 2, and notice from one of my vertices opposite the other one between the two bases, my perpendicular has to be between the two bases. And so I have a height of 28, okay? So my formula is area equals 1/2 times the height times base 1 plus base 2. Now these parentheses are extremely important. That means they want you to add the two bases before you do any multiplying. So I'm going to plug it in. Area is 1/2 times the height, and the height is 28, times base 1 is 12, plus base 2 is 24. Now, it's 1/2 times 28 times, what's 12 plus 24? 36. Now you want to calculate half of 28 times 36. And you should come up with 504. So that is the area of this trapezoid. Remember, this isn't a part of it. It's just helping me get the perpendicular. I could have drawn the perpendicular right here even. They just didn't. But sometimes the perpendicular is there. The perpendicular is the distance between the two bases. Okay, ready for one more? All right, what shape is this? It is a trapezoid. Notice that they have drawn the height from the one base to the next perpendicular. So let's think about, now I want you to notice, this time they're giving me the area, okay? So we've got our formula, area equals 1/2 times the height times base 1 plus base 2. And guys, this is why I tell you, always start with your formula. Because if you don't, you're going to plug numbers in incorrectly. Do I know my area? It is 164. Equals 1/2 times, what's the height? The height is right here, perpendicular to the base, and we don't know it, it's x. Times base 1, doesn't matter which base, you can use either one of them, is 12.8 plus 20. So I have 164 equals 1/2 times x times 32.8. Now I can go ahead and take half of 32.8 and I get 16.4, but I still have my x equals 164. And when I divide 164 by 16.4, I should come up with x equals 10. And that's my height, and that's what they wanted me to find. So sometimes they'll give you the area and have you find one of the missing pieces. And actually in the video, if you had watched the video, he did one where you had to find the base. That was a little more difficult. Okay, let's do our last one, the key one maybe. I don't know, maybe not. Okay, all right, once again, he gives me the area. But what is my shape? We're going to call that a rhombus, okay? A rhombus. So what is the formula for a rhombus? The formula is area equals 1/2 diagonal 1 times diagonal 2. Thought I had a kite on here and I'm not sure why I don't. But anyway, okay. So I have area equals 1/2 times diameter 1 times diameter 2. So now they tell me the area is 340 equals 1/2 times. Now be careful about your diameters. My diagonals. Here's my diagonal and here's my diagonal. So they tell me my whole diagonal this way is 20, but they're telling me only this part of my diagonal is x. What does that mean this part is? X. So actually this whole thing is 2 x's. X plus x is 2x. So I have half of 2x and half of 20. Well, I can go through and multiply. Let's do half of 20, which is 10, and then 10, half of 20 is 10, and 10 times 2 is 20. So this is 20x, because 2 times 20 is 40, and half of 40 is 20. So 20x, then I'm going to divide by 20, and I should come up with 17. That's x, and that's what they're wanting. Now, if they wanted the length of this entire diagonal, I would add x plus x, or 17 times 2, and get 34. Okay, so the main thing is as you're doing your assignment is that you write your formula. So you're going to